Alrighty, welcome back to the Forge preview track. So we've got an awesome talk coming up next, and it's going to touch on some themes that we've been touching on quite a bit in the keynote this morning and in some sessions throughout the day. And that is how we're positioning Forge and planning for Forge to enable us to have a trusted by default security model for ecosystem vendors that we can then pass on to our customers. Now, the session this afternoon is from Joël. Joël Kalmanowicz, who is obviously one of the co-presenters from the keynote this morning. He's he's our new principal product manager in ecosystem engineering. So definitely come and engage with him on Forge, but also all of your ecosystem-related topics. He's just a great guy to meet. And we also have ecosystem veteran Dugald Morrow, who's an engineering team lead on ecosystem engineering, and has also been our security champion for the Forge project. So he's been championing a lot of the security efforts we have and what we've shipped today. And he's also been doing a lot of more forward-looking thinking about how we might evolve the security and trust model for Forge in the future. So a warm round of applause for Joël and Dugald.
Hello, welcome. Yes, as Tim said, my name is Dugald Morrow, and I've been with the Atlassian ecosystem team for a few years now, mostly involved in Connect. But recently, I have been really looking into Forge security and trust. So yes, welcome again.
Hey, hello again. Thanks for coming. I'm Joel. As you hopefully saw me this morning, I've been with Atlassian fairly recently, joined this year. I was at Google for 7 years before that, worked across 3 developer platforms on various different products. I'm really excited to be here and to share all the things we've been doing and working on security and trust. Spent a lot of time working on privacy at Google as well, so I'm bringing a lot of that in here from my perspective. So let's get started. Now, we'd like you to prep questions because we will be able to have time for Q&A if all goes well. Okay. So you remember this slide? You've seen it a few times now. So the big barge on the left, that's kind of the vision we have for where we want to go in the future. And the little tugboat on the right is like what we have today that we're just showing you both of these. Well, this whole talk is focused on security and trust, and that's in the barge on the left, okay? It's vision. So that means that we're going to tell you all sorts of things that we have planned. We're going to tell you how we're thinking about this, how we think that this model is going to look, because we want to share it openly and get your feedback. So do let us know what you think about this. All right, here's what we have for you today. It is a packed agenda. We're going to start with why trust matters. Going to go a little bit deeper into some of this, and Dugald's going to talk to you about why it's hard to build trust as a developer. Then we're going to go through that security model in terms of the architecture, user interfaces, and something we're calling permits, which is a bit like OAuth scope, so you'll see more about that. Finally, we'll wrap up with a a comparison between Forge and Connect to give you an idea of what sort of trust model you're looking at in both of these and where the key differences are. Okay, with why trust matters. We called it out in the general session, and it's worth restating, but we don't have to restate it because our developer community is saying it too. You saw Vitaly Zurian called out in the keynote on day 1. Well, here's an amazing quote from him that we really love. It really captures the big reasons that we are working on Forge, because we want to help developers worry less about security to help customers have more trust in app performance, security, and handling data. Can I do a quick poll? Can I get all of you who are app vendors or developers to just start by raising your hands? Yeah? Okay, great. Keep them up for just a second. I'm going to do this in 2 quick stages. Keep your hand up if you've ever had a customer or a potential customer do an evaluation on your app for security, performance, or data handling practices. Okay, that's still quite out. Thanks. That's still quite a few of you. All right, finally, keep your hand up if you've lost a potential customer because of such an evaluation. Still a couple of you. Nice. So for the rest of you, I hope you can see that there are those of us who have worked on this and have actually lost business. So if you want to grow, trust is really important to this. When a customer is considering installing your app, increasingly, we are seeing them do more and more of these evaluations. This can be major friction to the point of the customer saying it's just not worth it. So, how do we think about trust? We can classify it into 3 main kind of sources. This is how I'm thinking about it here. Number 1, developers. If you're writing code for yourself, you could just stop here, right? Because you trust yourself. There's a caveat, and we'll come back to that in a minute. Because if you want to sell to customers, though, you need to establish trust. Now, major software companies like Slack, they have the reputation right? People just say, oh yeah, I trust Slack, that's fine. They can shoulder that burden of trust. But for everyone else, it can be easier to prove that you're trustworthy another way. You could get an independent audit and certification to demonstrate your adherence to well-known standards. Now, this can be very helpful in securing customers, but the effort and the cost can be prohibitive, especially for smaller developers. So that leaves one major remaining avenue, and that's the platform. Now, being the distributor of the code you write, we can also help build trust at a platform level. We do this in a few ways already, including our recently announced partnership with BugCrowd that I hope you all saw in the keynote as well. But what if we could take on more of the burden of trust? That's where Forge really comes in. Because if we can take on the burden of hosting and running your code, we have the responsibility and the opportunity to make that as trusted as possible so you don't have to. And even if you're writing something for yourself, you still need to be careful for your own sake. You might trust yourself, but at the same time, how are you going to evaluate your security practices? Because after all, software is constantly changing, and we're all building on top of a varying height stack with different things that we haven't built ourselves. So with Forge, we can manage a lot more of this, so you can just focus on building what you need. So, enough of how this all matters at a high level. You're still here, so you're still interested, I hope. Dugald's going to walk you through why it's so hard to build trust as a developer.
Thanks, Joël. So before explaining how Forge delivers on security and trust, I'm going to outline some of the challenges involved in building apps. I'm highlighting 4 areas of concern. Let's go through them one at a time. So security is often one of the most challenging aspects about building apps. An important part of this involves ensuring apps store credentials securely. Of course, the reason apps need credentials is to make API calls and receive webhooks. In Connect, apps need to be able to use credentials to encode and decode JSON web tokens. For OAuth APIs, apps need to be able to call authorization servers with refresh tokens to retrieve access tokens, which then allows them to make product API calls. It's easy to make mistakes in all of this. So performance and reliability are critical in gaining customer trust because of the strong correlation with quality. With Connect apps, performance varies based on how and where an app is hosted and how much effort vendors invest in their apps. So differences in performance and reliability is one reason customers have varying levels of trust in their apps they use. So cloud products are multi-tenant, which means apps must also be multi-tenant. This means apps need to be very careful they don't mix customer data. And customers are becoming increasingly concerned about where their data is being stored. Some customers need to know their data will not leave the Atlassian cloud, or perhaps only egress to specific locations. The last challenge relates to control and visibility over what the app can and can't do. API scopes provides a basis for access to REST APIs. Scopes are also the basis of user consent screens. So this provides some control and visibility into apps, but it's not enough for many customers.
So now we have an understanding of the main areas of growth. We'd like to share with you how we're thinking about building the security model for Forge, because if you haven't taken notes yet, please do. We really do want your feedback here, and it's going to help us make this robust and easy to use. So we're describing the model in terms of 5 pillars. The first pillar is hosted apps, which is the fundamental difference between Connect and Forge, right? Now in Connect, app execution occurs in the developer servers or in developer-controlled iframes. In Forge, app execution occurs in Atlassian-controlled cloud functions. The second pillar is a permission system. For example, permissions can be used by Forge to control who can deploy and install apps. And there are plenty of other ways that we can use permissions as well. The third pillar is managed auth. This refers to Forge's ability to take care of everything relating to authentication and authorization. As Tim and I showed you this morning, if we can just make it easy for you not to have to handle tokens or customer data, it really simplifies things down. And it means that we can make secure API calls on your behalf without needing to provide credentials. The fourth pillar is environments. Now, Forge provides you with multiple environments like development, testing, and production, again, as we outlined in the morning. But different policies can be provided for different environments. So that means Forge can give you a great development experience. So you could read logs in the development environment, for example, but not in production, which preserves user privacy. And the last pillar is this thing we've mentioned, permits. A permit is similar in some ways to an OAuth scope, but it applies to more than just REST APIs. We'll go into detail about that towards the end. But we think that this combination of pillars is a great way to achieve a secure and trusted app environment.
So now that we have a high-level sense of the Forge security model, we can dig in to understand a few aspects in greater detail. So this requires looking into various features of the architecture. So for a detailed explanation of the architecture, you may want to attend Patrick Struhl's talk this afternoon. For this talk, however, I'll keep to only aspects of the architecture that are relevant to security and trust. So Connect is baked into our cloud versions of Jira, Confluence, and Bitbucket. However, Forge is implemented independently. This separate implementation allows Forge to be integrated with any Atlassian product. With Connect apps, developers are entirely responsible for managing the hosting of their apps. But with Forge, developers simply use a command line tool to deploy their apps. And Forge apps are essentially a bundle of functions that are executed in response to certain events. Note that Forge apps are entirely hosted by Atlassian. Forge takes care of the provisioning of resources and has complete control of app execution. This makes Forge apps extremely reliable, which is an important factor in gaining customer trust. So having complete control of the runtime also allows Forge to provide managed APIs. The managed APIs allows apps to make secure calls to REST APIs without needing to manage credentials or provide tokens. And Forge apps can contribute to the user interface by responding to user events. And they can make API calls to Atlassian products and services. They can also make API calls to third-party products and services. And finally, Forge apps can receive events or webhooks from third-party products and services. From a security point of view, the interactions highlighted in red are the ones that make some customers nervous. For example, customers don't like their data leaving the Atlassian cloud, or for certain integrations, the customer wants to know that the data can only egress to a particular destination. In addition, apps that can modify data or administer a product can also be a concern. So we believe we'll be able to control these interactions by requiring a permit for each. So as we've said before, we haven't yet built or fully defined permits, but I will talk about them later. So since Forge hosts app code, controlling the app runtime is critical to security. So let's take a closer look at how the Forge runtime sandboxes apps from the environment in which they execute. So as you can see in this diagram, the sandbox comprises several layers. At the core of the sandbox is the packaged app code. The app isolate provides the sandbox that the app code runs in. So this is a V8 JavaScript isolate, which is the same technology used to run Chrome iframes. It's possibly undergone more security testing than any other software built. So isolates are customizable, which enables Forge to control exactly what the app can and can't do. Forge apps run within Amazon Web Services as lambdas. The node runtime is the code we execute as the lambda. The lambdas run using separate Amazon accounts to our normal services, and this allows us to minimize their privileges. So if you have a vulnerability that allowed an app to escape its sandbox, running under a less privileged account limits what it could do. So let's take a closer look at isolates, and in particular, how they are created from snapshots. We use Webpack to package the app code, the Forge API, and polyfills. The Forge API and polyfills provide complete control over what the app can and can't do. The Forge API provides Forge-specific functionality, whilst polyfills implement standard node APIs. So polyfills that have a security aspect to them comprise two parts. The first is the API, which lives within the isolate. The second part of the polyfill is the implementation. This is in the runtime layer, which cannot be accessed from within the isolate. So in the case of console.log, for example, we send log messages to our infrastructure, which allows us to control and manage their persistence as well as their access. So for example, in production environments, we assume app logs may have user-generated data, so we block developers' access to them. For the Fetch API, we make checks to ensure the customer has consented to the app making calls outside the Atlassian cloud. So now let's look at how the app sandbox isolates customer data. So this diagram shows an app being invoked by two customers. So now let's say the app uses a global object to cache data by issue key. Since issue keys are not globally unique, this pattern could easily result in data leaking from one customer to another. However, the way in which we invoke apps prevents this. So here's the sequence of operations when an app gets invoked. So remember how the runtime comprises several layers to form an app sandbox? Well, this shows how the sequence of operations make their way into the core of the sandbox. Note the middle step, where the isolate is created from a snapshot. So this is done for every execution to ensure the app function is always executed in a fresh environment. Or looking at it this way, two successive calls to the same app will execute in separate instances of the app. So going back to the example, the global object cache will always be empty and will never lead to mixing data from one invocation to the next. And so this approach isolates data at the runtime level. So I previously mentioned Forge APIs. Like some isolates, the implementation of the APIs lives in the runtime, which cannot be accessed by the app. So one of the APIs allows apps to call product APIs without having to manage credentials or provide tokens. In addition to being more secure, it simplifies app development and will reduce defects. The result will be increased trust. So here's some code illustrating a managed request to the Jira REST API. The first line instructs Forge to act as the user that the function was invoked on behalf of. So this could be the logged in user if they are interacting with the app's user interface. Alternatively, it may be the user associated with the app if it's been triggered by a product event, such as a workflow transition. So this line is the actual permit check. It ensures the app is permitted to interact with the Jira API. If this is the first time a particular user has interacted with the app, then this will fail and the user will be prompted to enter a user consent flow. I will talk more about permits later on. The last line is the actual request operation. To further simplify app code, Forge utilizes the context in which the app is being invoked to allow relative URLs to be passed to the request.
So far, we've mostly been talking about Forge from a back-end point of view. So let's look at the security and trust of Forge's user interfaces. To do this, let's revisit this architecture slide and simplify it a little more to focus on user interactions. So we can abstract away the Forge services to leave us with just the runtime that the app operates in and the Atlassian product that renders its UI. So now it's clear, the app function powers the user interface. And as a function, it's possible that we don't need iframes. Oh, sorry about that. It's possible because of the declarative user interface that we have, and because the function is sandboxed, that means that the UI which we render also is secure, because no app code is executing in your browser. Now that means we also don't need iframes to sandbox the apps. Sure, while iframes are awesome in many ways, they do present certain challenges, especially seamless embedding and mobile compatibility. So together, This all contributes to greater trust because we've sandboxed the user interface code in a seamless manner that allows us to control data egress, like with a permit. So let's finally talk about those.
All right, so we've mentioned permits a few times, but we haven't explained them properly yet. So we've conceptualized this scheme to greatly enhance customer trust by providing transparency into aspects of apps that represent risk. So I believe customers will be able to take advantage of this by allowing all users to install apps, not just their administrators. Or put simply, I believe we will be able to provide for democratized app installations. So permits can be thought of as permissions for apps. They identify what an app is allowed to do. An app must declare the permits it requires, but they are only granted after a user consents to them. The result is total transparency into what the app is allowed to do. So permits are conceptually similar to scopes, but they apply to more than just REST API. In summary, we can say that permits provides the mechanism for customers to consent to risk. So the permits model is pretty simple. An app can have any number of permits, and different types of permits can have different types of options associated with them. So there are two categories of permits, API enrollments and data egress. An API enrollment permit indicates that the app needs to be able to make calls to product APIs. The declaration of this permit can specify separate sets of scopes corresponding to requests made on behalf of the app versus requests made on behalf of users interacting with the app. And the granting of API enrollment permits involves users consenting to API scopes. Let's say an app wants to make API calls to both Jira and Confluence. Let's also say the app needs to make some calls on behalf of the app and other calls on behalf of users interacting with the app. So there are a number of different times the permits are granted for this. So the app scopes are granted for the app user, that is the user associated with the app, or otherwise known as the bot user, when the app is installed into a product. For this example, these scopes will be granted independently when the app is installed into Jira versus when it is installed into Confluence. So when a user interacts with the app may attempt to make an API call as that user. For each user, the first time this occurs will require that user to enter a user consent flow to consent to the app making requests on their behalf. The second category of permits relates to the ability of an app to egress data outside the Atlassian cloud. These permits recognize that some customers are wary of apps that send their data to third-party services. Data egress permits are presented and granted during the installation of the app. So there are 4 types of data egress permits. The network egress permit allows an app to initiate requests to external APIs. Although it's labeled network egress, this permit would be required even if an app only consumes data from a third-party service. When specifying this permit, you'd also need to specify the origins that the app needs to interact with. So the web trigger response permit allows an app to respond to webhooks from third-party services. This permit includes the ability of an app to select a product context in which to execute. So this product context, combined with an API enrollment permit with read scope, then allows the app to retrieve data from the product and return it in the web trigger response. So this permit also requires origins to be specified in its declaration. And the user agent egress permit allows an app to include links in the user interfaces it produces. This permit covers the case where the link may contain parameters that carry user-generated data. Once again, origins should be specified for this permit. And finally, the entity egress permit specifies the ability to copy data from one entity to another. An entity here refers to a product abstraction, such as Jira issues, Confluence spaces or pages, or even Trello boards. For example, without this permit, an app wouldn't be able to copy data from a restricted issue to a less restricted issue. And the declaration of this permit specifies the types of entities that data can be egressed from. So whilst going over the different types of permits, I referred to how they must be declared. This is done in the app's manifest, which is the Forge equivalent of the connect descriptor. So here's a snippet of an app manifest that illustrates what this looks like. In this case, the app is declaring 3 permits, 2 API enrollment permits and 1 network egress permit. The app wishes to read and write to the Jira API as the app user. In addition, it wishes to write to the Confluence API by impersonating the user interacting with the app. And finally, it looks like it's providing an integration with NASA because it's requesting a network egress permit with the NASA API as an origin. So let's take a look at the permits required for different types of apps. So we'll do this in the context of the model, where an app can have any number of permits, each with various options. We'll start with an app that updates Jira issues in response to issue transition events. So this app will only need a Jira API enrollment permit. For that permit, it will need the read scope to read data from issues and the write scope to update them. Note that conceptually, the app wouldn't need an entity egress permit if the app only reads and writes to the same issue in the same invocation. But in practice, this will depend on how sophisticated the integration between Forge and Jira becomes. The second example is an app that posts Slack messages in response to Jira issue transitions. It will need an API enrollment permit with Jira's read scope so that it can read data from Jira. It will also need a network egress permit whitelisting slack.com so that it can post messages there. The last example is an app that computes the total of all cells in a table row. This app only needs a Confluence API enrollment permit with read scope, since contributing to the Confluence user interface does not require any permits. And here's a screenshot or screen recording of it in action. So the app has been added into the page 4 times, once for each row in the table. So would it make sense for an app to not have any permits? Well, if we remember, the purpose of permits is to provide customers with transparency and consent to anything of risk, then I think the answer is yes, so long as the app could do something useful without possibly breaking trust. So this means it wouldn't be able to access any APIs, and it wouldn't be able to egress any data, but it would be able to contribute to user interfaces. So an example might be an app that counts down the number of days to New Year's Eve or some other important day. And by the way, it probably took me longer to create that animation than it would have to create the app. However, I think the value of Forge starts to show when we change the question. Instead of asking if it makes sense to have an app without any permits, it's probably more interesting to ask, what could a completely trusted Forge app do? So instead of having no API access, let's say we provide the app with read access to product APIs. But let's still prevent any egress of data. So the app can now be more useful since it's able to utilize product data in its user interface. However, it is still completely trustworthy because the app can't egress any data and it can't make any changes to products. So taking this theme further, if in the future we are able to offer a storage mechanism that guarantees data isolation and localization, then this will greatly extend the possibilities for fully trusted apps. So as a baseline, Forge provides strong sandboxing and control of apps that can provide fully trusted user interfaces. To support certain types of integrations and customizations, Forge also allows consented apps to extend beyond this trusted baseline. So in addition to this, it is my expectation that we'll be able to extend this trusted baseline over time. So if Forge is able to provide a basis for a broad range of fully trusted apps, then I would say we should be able to give customers the ability to allow all of their users to install apps, not just their administrators. So this is what we refer to as democratized app installation.
Thanks. So, many of you may be wondering whether Connect or Forge is going to be more suitable for you now. Well, first and foremost, keep in mind that Forge is still under development and quite a while away. Most of what we've just shown you hasn't even been built. Again, that's how fresh this sneak peek is. But let's do a little side by side. Let's see some of the similarities and differences from what we know. So both Forge and Connect sandbox their apps from Atlassian products. Connect apps run in iframes on app servers that are external. Forge apps run on sandboxed cloud functions. With Connect, data egress is opaque. So what this means is it's okay if you already know everything the app is doing. I had someone come up and talk to me yesterday saying like, hey, I have an external hosted server. Can I send data to it? I was saying, yeah, you just declare the URI and it's going to go over there. So no problem. But the thing is, you as the developer, maybe you know this. But if you don't, or if the customer doesn't know and you as a developer don't tell them, or they just don't really trust it, or any number of things, there's no way for us as Atlassian to guarantee this. It's opaque. So we have no ability to know or control where the data is going to go if a Connect iframe or server accesses it. In Forge, this is transparent because apps require this permit. So the permit declares where the data is going to go, and it requires consent before being granted. Now, on the other hand, Connect provides a lot of flexibility. Iframes are super versatile, and there are pretty much infinite possibilities for writing and hosting app server code. And with Forge, we've made the trade-off to constrain the way that your app is developed and executed, because Forge apps must be executed exclusively as Lambdas and have to be written within JavaScript, or at least something that compiles to JavaScript. And similarly, the types of UIs that you can build with Forge UI are also constrained. So you can see what we're trying to do here is offer you that choice that I mentioned this morning. If you need the freedom of rolling your own stack, go for it, as you can do today. But if you don't need all that freedom, if you don't need to take on the whole burden of maintaining, and not just your code, but trust throughout the whole thing, Forge can do much of this for you. So let's recap quickly what we've gone through today, because it's a lot. Let's start here. Sources of trust. We talked about the 3 different ways that I'm thinking about trust here in developers, certifications, or the platform, and how with Forge we're trying to bring it on into the platform so that it's easier for you as a developer, because it's hard.
We've outlined a range of concerns detailing how tough it is to build secure and trusted apps.
And we also outlined how the Forge security model has a number of unique aspects that combine to form a secure and trusted environment for your apps that customers can rely on.
So the architecture provides a secure environment for apps, but still allows for strong integrations and flexibility. An important part of this is the hosted app sandbox, since it allows Forge to completely control app execution.
Mm-hmm. And Forge apps can create fully trusted user interfaces without iframes, which allows for seamless embedding and mobile compatibility.
So Forge provides a baseline of features that will allow many apps to be completely trusted. Other apps that can utilize more risky features, but this requires consent. And the transparency of Forge should allow for democratized app installations.
And then finally, we recapped here really the balance between Forge and Connect, where if you need to roll it yourself, you can. But with Forge, we have a new option where we can take on so much more of this burden for you. So we're going to end a little early to give you some time for questions. That's Dugald and I. Thank you very much.
Cool. Well done.
All right, we've got a microphone.
Hi. How would you handle changes in the permit between versions of apps?
I love it. So I think the model that we're looking at is if you look at OAuth scopes, for example, if there's an increase in scope, you may have to require the user to grant consent to that. And the interesting thing about permits is that it might not just be the end user, right? We're working in an enterprise world here, so the admin may be the one who grants consent for a scope, or for a permit in this case. And similarly, if an admin grants consent to a range of permits or perhaps a range of URLs across apps, then they can also be the ones who can set a policy for how scopes could be upgraded in future. I say scopes of permits. So that's kind of roughly how we're thinking about it.
Yeah, and I would say it's likely that we'll probably be that previously non-consented version of the app will probably be still running until such time as that those new scopes or permits are granted. So it'll probably be, we'll have to manage that life cycle through that permit approval.
Mm-hmm.
Great presentation, thank you. So given the permits are such a strong security model, it seems pretty obvious that this can be perfectly audited also. Do you intend to expose all this to the admin of the installation? There's an audit log like as a feature for the enterprise.
Yep, I would say so. That would be an important feature, I would say, yes.
First of all, great talk. Thank you very much. As far as I understand, for some features, Forge asks for specific permissions in user-wise. When I think in the admin side, if an admin installs a Forge app and trusting that it will collect some data, it will do some things, maybe in the name of the individual users, and create a report. But what if some of the users doesn't give the required permissions to this app, and the admin was like sitting on his desk and thinking like, oh, I installed this app, it should generate results, but the users didn't give consent, so what should he do? She do send a mail and say that you should give permission to this app. Do you think like overriding permission or another system to overcome this problem?
You go first.
I can have a go at answering. So the question, as I understand it, is what happens if the admin installs an app, but the users don't sort of consent to the app making certain requests? Well, I think that will only, those types of non-consented requests, if you like, would only affect that particular user because it has to be made in the context of some sort of user interface that only they could see, whereas their colleagues may give the access and they're unaffected. So it's really only going to affect that particular user. The interaction's just going to fail for that particular user. They won't see the user experience of the app surface for them, if you like.
And on the admin side, I think what's really interesting is that in the end, we want to give the power to the customer to decide what they need to do. And oftentimes in this kind of environment, the admin is working in the company, the user is working in the company. The company may have a policy, which is we are okay with the apps that we install being granted the following scopes. And that's where we're also thinking about maybe it would be possible for the admin to just say the following scopes, which users would have to grant, are automatically granted because I'm the admin and they are all employees and this is part of our workplace. But that's up to them. So we're thinking about how we could reasonably balance that capability with individual user privacy in the workplace. Thank you. Yeah.
Just to expand on that, if you do, I think you have to do that for everything that runs behind the scenes. Like I'm thinking, of course, of conditions, validators, and post functions and workflows, because the workflow is enforced by the admin for each user, and it's not up to the user to decide whether that process should be followed or not. Reporting across multiple users is the same thing. Obviously, you want the data of everybody in a report, all your developers, not just the one running the report. So in all these cases, I think you need something that allows the admin, as soon as they install the app, to grant to say, just like in Connect, all these permits need to be granted by default for everybody, because otherwise the app won't work for me in my organization. That's especially true in larger organizations.
Yeah, and I think there's a question as to whether that would be something that's like maybe an example set of code that we provide in our documentation to say, hey, if you want to request all the permits up front, here's a function that just does that. That's one simple way we could do this. Beyond that, we could build something else out. But it's a great point that, at a minimum, the admin needs to know that it wasn't granted if they don't have the capacity or the will or the company policy to just do it. And then secondarily, just straight up when you install the app, perhaps granting all the things. And that's where I think it's an interesting balance, because if you're an admin and you install a Forge app and you expect that all these should be granted, and anyone who doesn't say yes, you're going to go and make them say yes, it might be better for everyone if you just clear the air and say, hey, our policy is everyone says yes, therefore I as an admin am just going to do it. So we want to balance like user experience for everyone here.
I think as a small addition to that as well, there's a difference between making a request that impersonates the user, which is something that we probably do need a user's consent for, as opposed to getting access to a resource that sits inside the site. So an admin installing an app, when they're configuring the permissions for the bot user, will always be able to say, hey, this bot user can access everything. So in terms of like a post function, like guaranteeing that a post function will run and have access to issues and comments and things like that, the admin will always be able to make that guarantee. It's just the ability to impersonate a user that we'd probably need consent for.
The current user, post functions run as the current user, because otherwise you mess up with the issue history. So you have to impersonate the current user that triggered the transition while running the post function that's part of that transition. And you can't even ask the user because it's not part of the workflow, and you don't want to ask the user because workflows by definition are enforced by admins throughout the company, even if you have tens of thousands of users.
So what I'm understanding is that we'd need some sort of functionality similar to in Connect, where you've got the act as user scope, where that is granted for during the installation of the app, and that the user doesn't get a say in that. Yeah.
Sorry, yes, agreed. Maybe we're running a little bit short of time. Maybe let's
we
have
can
a chat
follow up
after.
afterwards, if you like, because I would also debate that all functions, or most functions even necessarily act as the user. I think bot accounts are really interesting here. But let's get through a few more questions.
I think we're actually out of time, I'm sorry.
But yeah.
Well, look,
the rest
actually,
of you
it's
look-
lunch next, so we can, well, there's a long break starting now.
Yeah.
Maybe we can huddle up the front of the room if there's a few people who want to discuss this in a bit more detail.
Yeah,
But
yeah.
thank you again, Joel and Dugald, for an awesome talk.
Thank you very much.